Okay, so we got hospital 1, hospital 2. We're wondering if there's a difference in the proportion of patients that are admitted to the hospital. Maybe these are patients that come into the ER. But one thing we'd like to quickly do to start is to count up the number of admitted. This one you could do by hand because it's a small enough data set. But if you have a huge data set, you want to have a formula. Okay, and one formula we can do is we can write a conditional in Excel or in Google Sheets. You just type equals the word if, because we're checking to see if something's true. Open a parentheses. I want to check if cell A2 is equal to the word admitted. I know that it is, but I'm writing this formula so I can just make the formula run for everything. If it is, I'm going to write a 1. That's what the comma 1 means. And if it isn't, I'm going to write a 0 in this cell. So it's correctly done that for the first one, correct for the second one. So copy that all the way down. Okay, so for hospital 1, I could quickly calculate the sum. I could just write sum C to C. So that means all of the numbers in the column C. Add them all up. So there's 9 that were admitted. If you get good at it, that's quicker than counting it by hand. But for such a small data set, you could probably do this without. And there's 20 values total, so not admitted must be 11. Now just watch out. This is always calculating the sum of column C. So I'm just going to copy the value and paste here. I'm going to paste the value over the formula. So now you can see over here the formula is gone. That way I don't lose my value if I use column C again. Okay, we want to do the same thing except now I want to do column B. So start on B2 and then I'll drag this to paste the formula. So there, now it's they've put numbers for those words, and now we can do the same thing equals sum C to C. So there's 7 there, and again I'm going to paste over this so I don't, I could just type 7 I guess. So there's 7 that were admitted, there was 13 that were not admitted. So there's a difference, right? Hospital 1 admitted 2 more patients than Hospital 2 did. Is that enough to say that there's a statistically significant difference between these proportions? So in order to do that, we have to test the assumptions first, okay? The assumptions of a 2 proportion test are 1, that your data are obtained independently of one another. So that means that if I got a person admitted in hospital 1, that's not influencing the chance of person 2 being admitted. Okay. If the hospital is saying, well, we already admitted another person, we might as well admit another, then those 2 events are dependent on each other because one is affecting the other's chances. Okay. So you want to check for independence, but the big things we usually want to check in a stats class is that n times p is greater than 10 and q times p is greater than 10. So what that means is n is your sample size, which is 20 in this case, and p is the proportion of success. In this case, success, it isn't really the word, the positive connotation of the word success. It's being admitted to the hospital, okay? So the proportion of people admitted to the hospital, 9 out of 20 people. And if you multiply that by 20, we've got 9 here. So that's a little less than 10. So that means that this data set is not meeting the criteria. This number 10 is a bit arbitrary though, okay? Some textbooks use 5, I think, as the cutoff. So, and then just for completion, it already doesn't meet the criteria, but if we're using our textbook of n times p is greater than 10. Q times p is greater than 10. Q is just the complement to your proportion. So if p is the probability of success, so 45%, so 0.45, Q is just 1 minus p, so 1 minus 0.45. So my Q is 0.55. So you'd want to multiply that. Oh, sorry, that's written wrong. That's probably wicked confusing. I'm sorry. That's n times Q there. So you want to multiply that by 20. So it meets this criteria but doesn't meet this other one. So I checked this. It didn't meet the criteria. I think they might use 5 in some textbooks though, so if it's close for my class, that's okay. You can continue. So I've done that for hospital 1. You want to do the same thing for hospital 2. Check your n times p and your n times q. Okay, and once you've done that, you've checked the criteria for conducting hypothesis tests about proportions. Sorry, one last detail is you would want to make sure that your samples are simple random samples too. That's usually another criteria, meaning that you got this not by convenience sampling or some other bias method. But it doesn't. This is just a made-up data set, and for whatever research data you're analyzing, you'd want to check to make sure that they've done that. But that's in the hands of the researchers. That's not something we can check.